know by now. All right, what you will be held responsible for on this test. Okay, we take a look at cations. We should know these are metals. We should know that they are positive. Okay, but why are they positive? All right, let's take a look at sodium. You know what? We've used sodium a lot. Let's take a look at lithium. Lithium in your periodic table will have atomic number 3 and an atomic mass of 7. Okay. Well, yes, it is a cation. But what we should be able to see is we have 3 protons and 3 electrons. Okay? Remember, if it's on the periodic table, we assume that it's neutral. But it forms a cation. In fact, it forms a positive cation. But why? Okay. Take a look, and we have lithium with one little electron floating around its outer shell, that valence electron. Okay? It is much easier for lithium to go ahead and give this electron away to, say, something like chlorine. That has 7 electrons. It's looking to gain 1. It doesn't want to give away 7. Okay, it's like us. Alright, the reason fast food's so popular is it's easy. Well, it's easier for chlorine to just take 1 electron than it is to give away all 7. Similarly, lithium, it is easier to give away that 1 valence electron than gain 7 more electrons. Alright? So, lithium has the affinity to give away that electron. Alright? We're going to say that lithium went and gave its electron here to chlorine. Chlorine is now a very happy customer. It has the full octet, that noble gas configuration, in its valence shell. Lithium, in fact, is happy. Why? Because from here, that's not a smiley face, that's an arrow. Lithium now only has 2 electrons. Let me get that so you can see it a little better. Electron, electron. But remember, that's in its first outer shell. So 2 is the most it can have. It is happy. Alright? From here, we can see that if we lose this electron right here, that electron is gone. Well, we had 3 protons. Sorry, trying to get a different color. We had 3 protons and 3 electrons. It gives away 1 electron, and now that negative charge is passed on to chlorine. So chlorine has a negative charge. Lithium now has the positive charge. That is where this Li+, this cation, comes from. So let's take a look at polyatomic ions. All right. When we are putting these together, there are a few rules and common mistakes that happen. All right. So let's start with ammonium. All right, ammonium is NH4. Okay. It has a +1 charge. What this is saying is there is a nitrogen, and it has 4 hydrogens attached to it. Alright, so this is one singular compound. Okay, remember, one singular compound. So don't go spreading it around and you will see what I mean. In fact, you may have made some of these mistakes. Okay. We are going to combine ammonium ammonium. Sorry, upset stomach joke. Ammonium. And let's put that together with, say, a sulfate. Which is SO4 and has a -2 charge, or 2- charge. As we put these together, right, we see the plus, the cation, the anion. Alright. This positive charge we're going to crisscross like we've done so many times before. A common mistake is to go NH2SO. Well, now we have just completely changed these two compounds. This right here is no longer ammonium. Okay? It is not ammonium. This right here is no longer the sulfate we started out with. Do not change that. How we change these, how we put these together, is we do have our NH4 with plus and our SO4 with 2-. Keep doing your crisscross method. Alright, draw it out. I need to draw these out. It's alright. We can see that we're going to have 2 ammoniums. We have to put parentheses and our 2 outside of that. Now, we see that we're only going to have 1 sulfate. Don't bother with the parentheses. Okay? Right here. NH4, 2, SO4. Alright, this is correct. Okay. This, if I take out these parentheses, is not correct. That's super confusing. If we have multiple polyatomic ions, which both of these are, we have to have parentheses. Next slide, we'll try another one. So let's take a look. I already have lead written up, but we're going to combine lead with, say, phosphate, which has a -3 charge. Alright, we are using the lead 4. Alright. So as we combine these, lead plus 4 phosphate -3. Remember, just the numbers drop down. That's going to give us lead 3. Remember, lead is not a polyatomic ion, it's just a variable charge cation, so we do not need parentheses. But for our phosphate, we do need our parentheses. Now, I know it's been drilled in your head. Look at these two. You've done the crisscross method. There is no lowest number ratio that we can divide by, so right there. We put it together. Now, let's go a step further. We're going to name this. Alright, we know we have lead. Well, we know we have the plus 4. So remember, variable charge. Put our parentheses, and we know that this is phosphate. Remember, in ionic bonds, we do not change the polyatomic ion's name, and we only need the Roman numeral if we have a variable charge. Because remember, lead can be plus 4 or plus 2.